Here in Chapter 9, we're going to be combining Chapter 6 on matrices with Chapter 8 on probability. Let me show you how this relates to Chapter 8. First off, if we take a look at a tree diagram that represents this problem, you see that we first going to decide, okay, what is happening in the beginning? In the beginning, we've got people who drink brand X and people who don't drink brand X. And we're told that there are 10% of the people who do drink brand X in the beginning. So we'll put 10% on the line for brand X. That means, since there's only one other choice, the other one has to be 90%. And then we do our advertising campaign. And here's what happens. After the advertising campaign, there are some people who still drink brand X and some people who don't. And there's some people who switch to brand X. And of course there's some that still drink the other brands. We're told the probability that a person buying brand X stays with brand X is 80%. That means that the rest of them, the 20%, change to something else. And we also are told that 60% of those that didn't drink brand X switched to brand X. That means 40% still drank the other stuff. So the probability a person buys brand X, the first purchase after the campaign begins, would be the branches that end in X. And from Chapter 8, we know that what we need to do is to multiply out to the ends and then add those up. And so there's our probability. Now what we want to do is see how to employ matrices to do this. Now one of the things that helps in visualizing these problems is a thing called a transition diagram. To make a transition diagram, we put the two things that we have. They either bought brand X or they didn't. And then we take the probabilities, like 60% probability that someone that is not currently X switches to brand X. And so that would be they going from not X to X. So if we draw an arrow in the direction from not X to X, that would be a 0.6 on that arrow. And then the people who remained loyal to their non-brand X, we just put a little circular arrow that goes from not X back into not X. And the 80% probability of someone buying brand X again would be a arrow that comes out of X and goes back into X, and we label that 80%. The other 20% are the ones that switched to something else besides brand X. This is called the transition diagram. We want to learn to write a transition matrix. And here's what our transition matrix would look like. Much like what we did back in Chapter 6. We're going to create us a matrix. The rows of the matrix would represent the current state. And we have two states. They either buy brand X or they don't. And the columns will be the next state. They either buy brand X or they don't. And so these numbers are like this. The 60%, the ones that do not have X now but are switching to X, that would be this position. That means the ones that didn't buy X and kept on not buying X, which is this 40%, would go in this spot. And then we're told that 80% of the people that buy brand X are going to stay buying brand X. That would be 80% in this spot. And then the people who switch from brand X to something else would be the 20%. This is the transition matrix. To go along with this, we can also create a matrix that's called the initial state matrix. construct the initial state matrix, we want to take our two things that we're studying, X and not X, and leave them in their same order, and then attach the probabilities. Currently, the brand X has 10% of the market, so we'll put a 10% under the X, a 90% under the not X. This is the initial state matrix. We use a capital S with a little 0 at the bottom to mean the beginning matrix. Now here's the transition matrix that we came up with earlier. Now we're going to find, using these matrices, what's called the first state matrix. The first state matrix is nothing more than the product of the initial state matrix and the transition matrix. And so if we take out our calculators, type these in, do the product, this is what we come up with. Notice it's called S sub 1, 1 meaning the first state. Notice the 62%, same answer that we came up with on the tree diagram when we did it. The difference is, what if we wanted the second purchase? Well, we could continue the tree diagram, make another branch off of each one of those 4 that we ended up with. That's going to be quite a big tree diagram. However, we can do this a lot more expeditiously using matrices in our calculator. The second state matrix is nothing more than the product, the first state matrix, and the transition matrix. But if you recall, the first state matrix was the initial state matrix times the transition matrix. Now putting the p's together, we come up with the initial state times the square of the transition matrix. Now, this is pretty easy to catch on to. And you can take out your calculator and do the matrix manipulations. Multiplying S0 times P squared, we come up with this. Do you see that the 72.4 is the probability a person buys brand X the second purchase after the advertising campaign begins? What if we want the probability someone buys brand X on the 5th purchase? Now that would be the 5th state matrix. We get the 5th state matrix by S0p to the 5. On the calculator we get 75%. That's a lot quicker than multiplying all those branches out on a tree diagram. And do you see also that we could actually do the 20th state, the 50th state, and so on, just as easily as the first, second, or third state. Now on this one, we're going to strictly do this with the matrices and not a tree diagram, so we can see what the technique looks like. Now the key to this is to make the transition matrix. So let's see what a transition matrix would look like. We've got 2 situations, those that are homeowners and those that are renters. So here is how we write our transition matrix. We want our rows to be the initial state, homeowners and renters. We want our columns to be the next state. And then we take the words in the problem. 15.3% of homeowners became renters. That is this number, homeowners that became renters. The rest of the homeowners continued to be homeowners. This number is the rest. If 15.3% changed from homeowners to renting, then the other 84.7% continued to be homeowners. In the next sentence, it says 17.4% of renters became homeowners. Here's the renters. Here's the homeowners. Renters became homeowners. That is this number, 17.4. The rest, which would be these, had to stay renters. That is our transition matrix. How about the initial state matrix? Again, we want to keep things in order. Homeowners and renters. in the beginning it says 41.9% were homeowners. That is the number in the H spot. The rest, meaning 58.1, were renters. So we can answer the question, what percent of households will be homeowners in 2030? This was the 2000 census. Censuses are done every 10 years. So 2030 is going to be the third state. We need to do an S0 p to the third power. You can do that on your calculator. Which one of these represents the percent of households that are homeowners? If you keep everything in the same order, that's the 49.8%.